Hello everyone, welcome to my channel Vidyarthini's Academy of Computer Science Learn with Passion. In today's video lecture, we'll be learning about the shortest job first scheduling algorithm. In our previous video lecture, we saw about the first come first serve scheduling algorithm, and this is the continuation of that, and this is the next scheduling algorithm. Okay, and before we get started, if you like my video lecture, please do like, share and subscribe to my channel, and don't forget to press the bell icon. And now we are available in our socials, Instagram and Facebook. I have mentioned the IDs in the description box. Please do follow us and do support us. Now let's get started. So we are now in shortest job first scheduling algorithm. Previously we saw about the first come first serve scheduling algorithm. We solved the problems in FCFS scheduling algorithm, and we saw about the advantage and disadvantage. Okay, now we are in SJF scheduling algorithm. So these are the topics that we have already covered, and now we are in the scheduling algorithm. Under scheduling algorithm, we are now seeing the shortest job first scheduling algorithm. So before we start, as the name suggests, what comes in your mind? It is the shortest job that is given the CPU first. So this is the thing that we have to understand by the name shortest job first scheduling algorithm. So it is the process that requires the CPU for a shorter period of time, which is given first preference. Okay, so that is what they say. The CPU is given to the process which is having the shortest next CPU burst. Okay, so now let's see in detail. So this algorithm associates with each process the length of the process's next CPU burst. So a process, it is considering the process's next CPU burst. So next, what will be the time requirement of a process that is for this CPU. So it is talking about the time requirement, that CPU time requirement of a process which is shortest next. Okay, so in a lifespan of a process, it might require the CPU for a particular amount of time. Then it will go out of the CPU to do IO operation. Then it will again come and into the ready queue and wait for the CPU. So in that queue, in the processes which is waiting for the CPU, it will judge which is the shortest next CPU burst of the process, and it will give preference to the process that has the shortest next CPU burst. Okay, that is CPU burst in the sense shortest time requirement, shortest utilization of the CPU. Okay, so the job which requires the CPU for a shorter period of time will be given the first preference. Okay, so when the CPU is available, it is assigned to the process that has the smallest next CPU burst. Okay. So the third point is here you will get a doubt that if two processes are having the same CPU burst time, how you can decide among the shortest job. So here that is what is given in the third point. If the next CPU burst of two processes are the same, then FCFS scheduling is used to break the tie. So when two processes are having the same CPU time requirement, then FCFS scheduling algorithm is used in order to break the tie. Okay. So the most appropriate term for this scheduling method would be the shortest next CPU burst algorithm, because scheduling depends on the length of the next CPU burst of a process rather than its total length. So this is what we discussed in earlier stage. That is, it talks only about the shortest next CPU burst time of a process. So the more appropriate name for SJF scheduling algorithm would be shortest next CPU burst algorithm. But in all the books and in all the places, this algorithm is referred as shortest job first scheduling algorithm. But it would be more appropriate if we say shortest next CPU burst algorithm. This is what we have to understand. Okay, and we have already seen about what is preemptive and non-preemptive. So SJF is also of two types. Shortest job first is of two types, that is preemptive method and non-preemptive method. So this is what we'll be seeing in the next slide. Okay. So here we have an example for shortest job first scheduling algorithm, non-preemptive method. Okay, consider the following set of processes with the length of the CPU burst given in milliseconds. So here you have 4 processes, that is process ID is given P1, P2, P3 and P4, and their respective burst time, that is CPU requirement time is given here. So process P1 has the CPU time requirement, that is the burst time of 6 milliseconds. P2 requires the CPU for 8 milliseconds. P3 requires the CPU for 7 milliseconds, and P4 requires the CPU for 3 milliseconds. So remember that we draw the Gantt chart for FCFS scheduling algorithm. Likewise, we will be drawing a Gantt chart for shortest job first scheduling algorithm here. That is here what you have to understand is we are considering that all the processes arrive at the same time. So if it is preemptive, we have to have one more column called the arrival time. But since it is non-preemptive, we have to understand that all the processes have arrived at the same time. So among the 4 processes, which is the smallest process, here the process P4 has the smallest time requirement of 3 milliseconds. So process P4 will be assigned the CPU at the first. So process P4 will be the one which gets the CPU first, and it will be using the CPU for 3 milliseconds. Next, which is the smallest next process? The smallest next process is process P1. So P1 will be getting the CPU next. So it will be using the CPU for 6 milliseconds. So total CPU utilization as of now would be 9 milliseconds. So this is what is given in this Gantt chart. And the next shortest job after P1 and P4 would be the process P3. P3 will be using the CPU for 7 milliseconds, and the total utilization of the CPU now is the 16 milliseconds. So after 16th millisecond, process P3 will get completed, and finally process P2, which has the time requirement of 8 milliseconds, will be given the CPU. So totally CPU will be used for 24 milliseconds by all these processes. Remember here you are understanding that all the processes are arriving at the same time, and after all the processes have arrived, you are that is this SJF non-preemptive method is judging which process is the smallest one, and it is assigning the CPU according to the processes which has the smallest CPU burst time. Okay, so when we calculate the average waiting time here, it would be like waiting time for P1 is almost 3 milliseconds, and waiting time for process P2 is 16 milliseconds, because it is the one which is given the CPU last, because it has the time requirement of 8 milliseconds, and waiting time for process P3 is 9 milliseconds, and waiting time for process P1 is 0. Waiting time for process P4 is 0 milliseconds. So when we calculate the average waiting time, here the average waiting time is 7 milliseconds. So if you want, you already know how to calculate the average waiting time for FCFS scheduling algorithm, and if you calculate the average waiting time, it will be more than this SJF scheduling algorithm. Here it is like the smallest job is assigned to the CPU first, so that it need not wait till the larger process completes the CPU work. So it decides between which process is the smallest, and it will send that process to the CPU first, so that it will complete the work and it will be assigned to the next process soon, and it need not wait for a longer period of time. So that is the idea behind this SJF scheduling algorithm, and this This one is the non-preemptive method. So this scheduling algorithm is the non-preemptive SJF scheduling algorithm. Okay. So the next is the example for SJF scheduling algorithm, preemptive method. So what is preemptive? Preemptive means you are forcefully taking out a process from the CPU and giving the CPU to a higher priority process. That is forcefully stopping a process which is already running in the CPU just to give the CPU to a higher priority process. So here the higher priority process would be the process which is the shortest. So now we have an example. Let's see that. Consider the following for a process with the length of CPU burst given in milliseconds, and the process arrive at the ready queue at the time shown. So here first let's understand the question. The process ID is a process P1, P2, P3 and P4, and you have to remember that is here you have a column called arrival time. Since it is preemptive, you have to understand when the process is arriving. So you have something called as arrival time and a burst time. Burst time that is for a process P1 the time required is 8. I will tell you why I have kept the 7 in bracket later when I am explaining. So the total time requirement of P1 is 8, that is the burst time. Process P2 the time requirement is 4, process P3 is 9 and process P4 is 5. So arrival time of each process and the burst time of each process is given. Okay. Now let's draw the Gantt chart. So you are getting the process P1 at time 0. So at time 0 it is a P1 that is ready in the ready queue and it is getting the CPU, and whereas at time 2 that is at the time 1 that is at the time 1 process P2 is arriving with the burst time of 4, which is less than 8. Actually P1 is used the CPU for 1 millisecond. After 1 millisecond only process P2 is coming. So that is the reason I have marked as 7. So 8 minus 1, 7. The remaining time the P1 requires the CPU is for 7 milliseconds, for which the CPU has to be utilized by the P1. But since the higher priority is given to the shortest job, P1 is forcefully stopped or forcefully taken out from the CPU, and the CPU is given to the process P2. So P1 is taken out of the CPU and process P2 is using the CPU, and it will be using the CPU for 4 milliseconds. Why? Because the remaining process P3 is coming by 2 second millisecond and process P4 is coming by 3rd milliseconds, but their burst time is greater than 4, that is 9 and 5. So process P2 will be using the CPU for the next 4 milliseconds. So after P2 is getting the CPU for at the first millisecond, and it will be using the CPU for the 4 milliseconds, and it will be completed, and after 5 milliseconds you have to decide between which is the smallest. So it is like P1 is waiting in the queue with 7 millisecond burst time, and P3 is waiting in the queue with 9 milliseconds, and P4 is waiting in the queue with 5 milliseconds, which is the smallest among the three. So next the CPU is given to process P3, that is process P4, sorry, and it will be using the CPU for the next 5 milliseconds. So totally 5 plus 5, 10 milliseconds. After 10 milliseconds of waiting time, process P1 is getting the CPU. Why? Because process P1 is having 7 millisecond burst time, and whereas process P3 requires the CPU for 9 milliseconds. So since P1 is the smallest, it is getting the CPU next. So it will be using the CPU for next 7 minutes. So totally after 17 milliseconds, P3 is getting the CPU, and it is using the CPU for its burst time, that is 9 milliseconds, and totally CPU used for 26 milliseconds. Alright. Okay, now what is the formula to calculate the waiting time? So here is the formula for calculating the waiting time. Waiting time is equal to total waiting time minus number of milliseconds process executed, which is that is number of milliseconds for which the process has already executed, and minus arrival time. So we'll be calculating the waiting time for process one by one. So waiting time for process P1 is equal to 10 minus 1 minus 0. Why? What is this 10? The 10 is the waiting time of process P1. It has waited for 10 milliseconds, but then it has already used the CPU for 1 millisecond. So 10 minus number of millisecond process executed, so 1 millisecond, and arrival time, it is the one which arrived first, so arrival time is 0. So totally the waiting time of process P1 is 9. So waiting time of process P2 is equal to, P2 has arrived at the time 1 millisecond, it came by 1 millisecond, and number of milliseconds process executed P2 didn't get executed before because it is coming in the queue only by the first millisecond, so minus 0, and minus arrival time. When it came only after 1 millisecond, so minus 1. So it is coming and getting the CPU immediately when it comes. So 1 minus 1, 0. Waiting time for P2 is 0. And waiting time for P3 is the one which is getting the CPU last. So it is getting the CPU by 17 millisecond. So our total waiting time is 17 minus number of milliseconds process executed. Did it get executed earlier? No, it didn't get the CPU before. So number of milliseconds process executed is 0 minus arrival time. When did process P3 came? It came in the second millisecond. Okay, so minus 2. So total waiting time 17 minus number of milliseconds process executed is 0 minus arrival time is 2. So totally waiting time for P3 is 15 milliseconds, whereas process P4 it is coming, the total waiting time of process P4 is 5 minus number of milliseconds process executed. It didn't get executed earlier, so 0 minus arrival time. P4 is arriving by the third millisecond, so arrival time minus, we have to minus, so 5 minus 3 is 2 millisecond. Thus waiting time for process P4 is 2 millisecond. So average waiting time here is 9 plus 0 plus 15 plus 2 divided by 4 is 6.5 millisecond. Alright. So one thing we have to understand in case of shortest job first scheduling algorithm, which is preemptive, is the process that gets the CPU is the one which has the shortest remaining CPU burst time. So that is when you see here, it is P1. P1 has the CPU burst time, that is the remaining CPU burst time 7. So it is getting compared and it is getting allocated before P3 because it has the shortest remaining CPU burst time of 7 milliseconds. So it is getting allocated before P3. So P1 is getting the CPU at 10 millisecond, and before P3 it is getting the CPU. So one thing we have to understand is that the process which has the shortest remaining CPU burst time is the one which is getting the CPU first. Okay, so that is what is given in the next slide. Preemptive SDF scheduling is sometime called shortest remaining time first scheduling. So the process which has the shortest remaining CPU burst time will be the one to get the CPU first. Okay. Now that we understood, it is better than FCFS scheduling, and does this SDF has problems? Yes, of course it has few disadvantages. Let's see that. We are going to see about the problems with SJF scheduling. So what are the problems with SJF scheduling? So the problems with SJF scheduling algorithm are the real difficulty with SJF scheduling algorithm is knowing the length of the next CPU request, knowing the length of the next CPU burst. So it is used that is it in practicality in order to know the next CPU burst of a process. See, you can always get the total length of the process, but you are talking about the next remaining time, right? It is always difficult to get the length of the remaining time. So it is really difficult with the SJF algorithm to know the length of the next CPU request. Practically, it is difficult to know the next CPU request. Okay, so so that is the problem with this SJF scheduling algorithm. Although the SJF algorithm is optimal, it cannot be implemented at the level of short-term CPU scheduling algorithm. So in order to there is a difficulty in getting the CPU burst, that is the remaining CPU burst of a process. It cannot be implemented. So you might ask, when we are not implementing this SJF scheduling algorithm, why we have this SJF scheduling algorithm preemptive method? It is not like that. Though it has this problem of difficulty in knowing the next CPU burst time of a process, it can be used in some way. So that is what we'll be seeing next. So there is no way to know the length of the next CPU burst. So they say it is having the difficulty that we are not able to know the processor next CPU burst time. That is one thing we have to understand here is it is easy to understand or get the process total length, but it is difficult to know once the process is getting the CPU and it is coming out of the CPU, what is the remaining CPU burst time. That is the difficult part, and we will not be able to judge that remaining time. Okay, so what we will do in order to know that is, so that is only when we know the only when we know the remaining CPU burst time, we can use this, right? So in order to know that, we'll do few things. What are they? So one approach is to try to approximate SJF scheduling. So you will be trying to approximate the length. That is, we may not know the length of the next CPU burst, but we may be able to predict its value. So we will calculate it approximately. What will be the next CPU burst time? We'll be calculating it approximately. We expect that the CPU burst will be similar in length to the previous one. So we think that the next CPU burst time will be similar to the previous one, right? So by approximating it, we can use this approach. Okay, and thus by computing an approximation of length of the next CPU burst time, we can pick the process with the shortest predicted CPU burst. So according to our prediction, which is the shortest CPU burst time process, will be getting the CPU next. So thus this is how we can use this approach, and I'll be seeing you in my next video lecture. What will be the topic next is, next we'll be seeing about the priority scheduling, and this is all about shortest job first scheduling algorithm. In case if you have any doubts, please do comment below. I'll try my best to answer all your questions. And if you like my video lecture, please do like, share and subscribe to my channel, and don't forget to press the bell icon. And we are available now in our socials, Instagram and Facebook. Do follow us. I've mentioned the links in the description box, and do support us. Thank you.